The Moving Iron Podcast is brought to you by these great sponsors. Are you looking to value your equipment more accurately, target the right buyers and close more deals, reach your ideal customer? Then look no further. Fusible isn't just about ag data, it's about action. Our best-in-class solution empowers you to value your equipment accurately, make informed decisions, and find the perfect prospects. Ignite your dealership's growth at fusible.com/movingiron-podcast. Out in the field, every decision counts. You wouldn't plant without testing your soil, so why would you prospect blind? Introducing EDA, your one-stop shop for ag equipment intel. EDA goes beyond specs and prices. You get deep dive data on every piece of equipment like UCC filings that help track ownership changes and uncover potential sales leads. D&B firmographics, which help you understand the financial health and buying power of potential customers. Market trends that help you stay ahead of the curve, and insights on equipment demands and pricings. With EDA, you're not just looking at data, you're seeing opportunity. You find the right buyer, sell smarter, and build lasting relationships. Visit edadata.com for your free demo and unlock the power of knowledge. For over 80 years, Iron Solutions has been your go-to data source for ag dealers, lenders, and manufacturers. Get powerful appraisal and value forecasting tools that fuel profitable decisions anytime, anywhere. Get your free demo at ironsolutions.com. Iron Solutions, confidence in every click. Today, there are many ways to finance ag equipment, but nobody delivers simple, fast, or flexible financing like AgDirect. Learn more about your options to buy, lease, and refinance equipment at agdirect.com. Valley Transportation has been hauling ag and construction equipment across the country for the past 33 years. Call Parker at 800-657-4910 for all your trucking needs. At Valley Transportation, our goal is to help you reach yours.
When you partner with Axon, you immediately gain access to a full range of products and solutions designed to meet the complex needs of today's grower. We carry all major brands and sizes of tires and wheels. We specialize in large diameter wheels for large equipment. We have one of the largest OEM replacement wheel inventories in North America. Known for extreme flotation setups, duals, and triples, we have wheels for all makes and models of tractors, sprayers, combines, and grain carts. If we don't have the wheel in stock, we'll custom build, sandblast, and paint in-house. There isn't a more vast inventory in North America dedicated to helping dealers move more iron. With facilities on the West Coast and in the heart of the Midwest, leverage our 230,000 square feet of indoor inventory to solve any problem a grower may have. Move more iron with Axon.
Moving iron in the 21st century. Hard-working people working hard for you and me. Moving iron time and time again. Through the years you'll find us here. Moving iron.
Hello and welcome to Moving Iron Podcast. I have got a return guest from a very long time ago back on the podcast, Colin Hurd with Mach now. At the time, he was with Smart Ag way back when. He had to come on the podcast and talked about that. That was podcast number 50. And if you're keeping score at home, we're over, 1,200 podcasts now. So, Colin, it's great to have you back on the podcast, man.
Casey, it's great to be back. It's amazing how you've progressed since those days, and I'm glad to see you're still in business and it's working out. So yeah, I'm excited to be back and join you for a conversation today.
Yeah, man, I'm excited about this. You always have really innovative stuff that you're doing, Colin. Every time I read about you, either on LinkedIn or some ag-based stuff that pops up, and the company you started now is no different than that. You've got a company called Mach, and basically Mach is the components that needed to make things autonomous. So I guess I'll let you give a little more detailed explanation of what Mach is than what I just gave there. But talk a little bit about what Mach is and what you're doing.
Well, so the way I explain it to my 6-year-old is that we make machines turn into robots. And that's the best explanation for him. He loves robots at this age. And so, but in reality, that's essentially what we do on a day-to-day basis is we make robots. And The way we do that is we find different equipment manufacturers from all over the industry. Ag is primarily our focus, but we work with a variety of companies that build a machine, and they say, look, we know that our customers need to leverage this machine in an automated function to drive their bottom line, become more efficient, become more safe. And in most cases, a lot of the equipment that's being built is not always being built by massive OEMs like John Deere or
Right.
Case. And so a lot of the OEMs below that kind of level really do need reliable, independent technology partners to do this stuff. And autonomy is hard. It's becoming easier. So from the time I started, and we were talking way back in the Smart Ag days, it's become a lot easier, but there's still a ton of technical challenges to making something that works reliably, and it works in a lot of different environments that customers are in. And it's ruggedized enough to survive the harsh reality of, a farm or a farm field. And that's really where Mach comes in. So we provide not just a software solution to enable a machine to do whatever function automatically, but we also provide the hardware stack required to bring the compute to the machine, allow it to have that intelligence to leverage all the sensors that it needs to know if it's doing a good job safely. And so once we understand what the requirement is from these customers, we'll typically start with a project. We'll provide them with some ideas on how we can make it work, and we'll create a test machine and then ultimately provide a solution that they can integrate on those machines as they go to the market.
Yeah. So this is the part that I've always found, just the idea of watching a machine drive in the field by itself with nobody in it. Like when I used to watch the grain cart tractor, and I'd see the grain cart flying around the field and it'd just come up and pull. I mean, it was like magic, right? It was just like one of those things like, this shouldn't be doing this. There should be some level of, there's somebody someplace with a remote control making sure this does what it's supposed to. But it was just amazing to watch it go do what it does, right? Like you said, it's come a long way since then, right? The cabless tractor at farm shows have been, you've watched those, the evolution of those for the past 15 years. They never go anywhere. They never actually do anything. They just kind of sit there. But the idea of this autonomous machine going and working and doing its thing has always been just one of those things I just watched with amazement, right? This, I think autonomy 10 years ago was always a cool idea people thought about and were ready to maybe go down that path. But it feels like as we inch closer to autonomy, where it's actually going to be a real thing, do you feel like you see a level of, because I feel like this, I feel like there's a level of pushback on the autonomy level that I quite frankly wasn't expecting to see happen. I guess as you look at this and you kind of go through these motions, what's some of the sentiment you're getting about that when you start looking at autonomy that way?
Are you talking about pushback kind of from a farmer level or an end user level?
Yeah.
Yeah, skepticism really about,
right.
Hey, is this actually going to create value?
Yeah, can I really use this like they say I'm going to use it?
Yeah, and unfortunately, I think part of that pushback is justified,
Sure.
And I would say there's a lot of solutions out there today that overpromise and underdeliver.
Mm-hmm.
Part of that is the messy side of innovation, where it's super easy to prototype something, honestly, today. There's open source software, there's off-the-shelf hardware.
Sure.
In fact, one of the first inspirations to me to get into this business was a guy in Canada who I'm sure that you've probably heard of, who basically took an Arduino, which is like a $10 computer board, and a Raspberry Pi, which is a $20 computer, hooked it up to his grain cart tractor and started using like an open source drone controller software to make it work, and did it. I think he probably spent $700 on the system and was like, "Hey, look, I can use this." And so there's this false concept out there of like, "Hey, we can automate stuff really quickly." And so you end up with a lot of early stage tech startups that come into the space with very lofty promises. And in many cases, they've let down the customer. And I think that that's a challenge the automation industry has to overcome to a degree. It's a really big focus for us at Mach. I've been around the block, now at least once on this stuff. And so I definitely have an eye for like what is real and what can work at scale versus what is kind of still has 4 or 5 years of R&D to get to a point where a farmer can depend on it, just like he depends on his tractor on a day-to-day basis. Because that's ultimately what's happening, right? Is now, you used to depend on, turn the key on your tractor every single time it starts up and it works, right? You need that to feed your cattle every day. You need it for whatever the job is. Well, now all of a sudden, if it's a computer system that's in that tractor, it's got to be just as dependable, or that entire piece of machinery is compromised. And so it's also a big investment, right? And one of the things that ag doesn't always do a great job of is allowing farms and farmers to avoid risk. If you think about it, there's a lot of risk that farmers have.
Risk, yeah.
And I think, unfortunately, a lot of times this technology risk has been shifted to the farmer, and I think that's the wrong way to do it. I think you need to provide ways where farms can get comfortable with this machinery and not take all the technology risk, especially if it's early stage tech, like what's some of the stuff that's out there.
One of the big differences, I think, in this kind of what you're talking about, one of the big differences between this and, say, the introduction of AutoGuide was that AutoGuide was you're still in the tractor, you're still functionally having to make the machine work. You got to push the buttons, and early days you still had to raise implements and do those things and do all the stuff. Now you've got automation where all that stuff happens at once now, and you're just kind of hanging out inside the tractor. To me, I think some of the pushback that I see from guys is that they don't want to stop being in the combine, right? They don't want to stop being in the tractor. That the thing about farming and ranching, I think that is lost by some of the people coming into the space is that it's a lifestyle, right? It's not a job. It's very much a lifestyle. So I think when you look at some of the stuff, that's where I think some of the pushback comes from ultimately at the end of the day is that, I might not be able to I don't have to set my combine during harvest now. What am I going to do with myself, right? And I think there's some of that angst, I think, that comes up there, I think, a little bit sometimes when you have conversations with guys about this. When you are looking at this, so John Deere's come out and said, hey, we're going to have this fully autonomous farm by 2030. They start out with a chisel plow, I think. That's something they start out with their first autonomous tractor. Tillage piece. Really looking at your website here and kind of going over stuff before we started recording here. I mean, one of the biggest places where you've seen a lot of the autonomy really take hold and really run is on the orchard and vineyard side of the business, right? Obviously, that's a very labor-intensive scenario. You got a lot of people hand picking this stuff and doing those kind of things, but you're seeing some machines come in. I've seen everything from the spider looking thing with scissors that picks the strawberries to the nut tree sprayer that goes into the orchard and does those kind of things. Talk a little bit about that evolution and how Mach is fitting into that.
Well, it's actually in so far as I know today, the only space where autonomy to a certain degree is just commercial off the shelf, meaning that you can go to your John Deere dealership in the valley and buy a autonomous orchard sprayer. Mm-hmm. You can't go buy an autonomous tractor from John Deere today to pull a chisel plow. I don't think it's on the market yet.
No.
And so it's really an inspiration. It's a big driving factor for part of the reason why we formed Mach. And so maybe I can tie in some more background onto Mach and my background a little bit more. But the company that I attribute most of the success to in that space is a company by the name of GUS. So GUS, it stands for Global Unmanned Spray System. They were a startup essentially that decided they were going to build an unmanned sprayer and really to solve their own needs. They were a big custom spraying operation and started building this and used it in their own operation for the first few years to kind of work any bugs out. But they made it sort of mainstream in that industry to use autonomous machinery. And you've seen a ton of follow-up activity from that, where a bunch of other startups and other companies have also worked to embrace autonomy in that space. So, my last company where we last met was called SmartEgg. SmartEgg got purchased by Raven Industries in 2019. We had a product called AutoCart, which Raven then rebranded to OmniDrive. And it was to do the autonomous grain cart function. Now, while I was at Raven and we were working through a whole bunch of different engineering things, that some were self-inflicted challenges and others were just getting it, into their ecosystem. But one of the key things that we were missing, and even later on as Raven got acquired by CNH and I had transparency into what CNH had been working on from an autonomy perspective for years, the biggest piece that was missing was commercial scale. And the value of that from the standpoint of autonomy is critical, because until you get to a certain amount of scale, you really can't understand all the limitations and edge cases of a system. So you've got some sort of a critical mass that's required, I think, to have a commercially viable product.
Right.
And this big $1 billion company that I'm at, tons of engineering resources and budget focused on this problem. We're sitting over here trying to figure out how to get to kind of square one. And there's this startup in California that is, selling hundreds of vehicles that are autonomous, and they're working. People are buying them, using them. And so as I dug deeper, I discovered the key piece of underlying technology that they were leveraging in that space was from a company out of Maryland called LSA Autonomy. LSA had been about 10 years in business, primarily doing work for the Department of Defense on a huge variety of different off-road vehicles that the government wanted automated to do whatever. And they had been supplying Gus the core autonomy technology for that system. And so as I started to understand kind of what that technology entailed and get to know the people at LSA, it really was clear to me that there was an opportunity here to take what they had done and take that to a lot of other companies in the space that were looking for this type of technology, and also bring in some really ruggedized hardware to support that. And so we purchased LSA Autonomy and merged another company out of Iowa together to form Mach. And so that was kind of the background and the basis of the core system that we have today. And I think that's really the value proposition that we bring, is that we have this hardened system that's been field tested and ruggedized across hundreds of vehicles and deployed, and that's what's really exciting to me today, is to be able to expand on that.
Yeah. All right, so I'm looking at your website here, and like I said before we started, got to looking over stuff. You really kind of got a finger in about every one of the industries out there that have anything to do with machinery. You've got agriculture, construction, industrial, maritime. You got some, just like you talked earlier, you were doing some stuff with the U.S. military on some various things that are out there. As you look at this, there's so many things that are going to be autonomous in the future and not that far away. But as you look at this, about every manufacturer is rolling out some stuff. I'm looking at your website here, and you've got a Vermeer. I can't remember what that thing's called. It's a bale mover.
Bale hawk. Yep.
Bale hawk. Yeah, there you go. And kind of working through that. Talk a little bit about how your technology is working with that.
It's a great example of an OEM who came to us with a lot of technology already developed. Vermeer's a big company, and they have a lot of really smart engineers there. And so they spent quite a bit of time developing this autonomous round bale mover. And there's a few pieces of the system that they didn't have solve for, and we were able to step in and help support them. And so in that case, we're not supplying all the technology required, but a lot of it's Vermeer's technology, and it's pretty impressive what their team did there. But we were able to help them with a few components of that in terms of the user interface and some of the connectivity required. But it's a really cool product that you basically just, it's kind of like a set it up and walk away type product, which there's not a lot of that in the autonomy space yet. Even Gus, you're still supervising those machines as they're in the field. But this is something where, I don't know, I'm sure you've moved around bales before, but it's was like one of my least favorite jobs ever, growing up and working on a farm, because it's so kind of unstructured, and you're always like in this decision mode about, do I go to this bale or do I go to that bale, which is the most efficient way to do it? And it just, I don't know, by the end of the day, I was exhausted and felt crazy. And not to mention the difficulty of just, not trying to bust bales and they're rolling down the hill. It's just a sucky job. No one likes doing it, I don't think. And so anyways, you just put this thing out in the field, you give it a boundary, and you say, pick up the bales and stack them in a line. You tell it where the line should be. And so it just kind of goes and searches throughout the entire field, finds all the bales, loads them up, and then it brings them back to a stack line. And they're all nicely organized there, so you can pull in with a semi-trailer, load everything up, and be gone. Just kind of set it up and let it work. It's really cool.
Yeah. Yeah, they have there's some of that, like, again, it kind of goes back to what I said earlier, just some of that stuff looks like it's almost like there's a remote control guy someplace or someone hidden in there that you can't see doing whatever they're doing. But this machine here there's no way for anyone to set. So you can't, no one can hide in that. So that's very,
exactly.
very, very impressive to watch these machines move. So the other side of this, I think is the hard part of autonomy, just like you talked about, is when we start looking at the implements and how you use the implements and the interface, the human interface on implements, is that you can look at a monitor and say, hey, my planter's planting or my planter's not planting, right? Assuming that the sensors are working like they're supposed to be, right? You can look at different sensors and stuff on your tillage pieces and know how deep you are and all that kind of stuff. And you can really get a feel for what's going on out there. The hard part about the autonomous side of that is now you have to have to interface that with a computer of some kind that is now making those decisions based around a set of criteria that takes human reasoning to get things pushed along. When you look at stuff like, and I think this is kind of that, to me, is there's two things I think that really change the speed of which autonomy is going to take place. One is how fast before you have a truly autonomous planting scenario. And then the second one is, when do you have a truly autonomous spraying scenario? Those two things to me kind of set the table that once you have those two things developed, the harvesting, I have a hard time believing that some farmers are just going to set back. They're going to have a hard time saying, like, I'm not going to let a machine plant my crop, and I'm sure as hell I'm not going to let a machine cut my crop, right? So those two things are huge things you have to overcome. But once you overcome those, I think then you can slide into some other stuff. Tillage probably would come way before anything else as far as that goes. But the two big hurdles, in my opinion, are planting, spraying, and harvest, right? Yep. So as you look at those things, obviously there's machines out there now you can do it. I've watched plenty of videos watching that stuff. Every spring it seems like there's the guy that's got the seed sack on the seat of the tractor and jumps out and watches his tractor do a couple loops while he's sitting there watching them. But from your professional opinion and the stuff that you see happening now, Colin, how far away are we from the truly quote unquote autonomous farm? How close are we to that? Something like that.
Those three use cases that you bring up, the harvesting, the spraying, and the planting, are probably the most critical points in the crop cycle in terms of getting it right. There's just very little room for error on any of that, and you pay for it, really directly if you screw up. And so, I agree that those are probably going to be the last ones left. when everything else maybe runs autonomously. But there's a ton of different caveats to making any of those use cases autonomous. My guess is it's probably in the 8 to 10 year time frame before you see something like for those
widely accepted type deal.
Yeah, that's even really just viable commercially.
Right.
Now, in certain sectors, you're going to see it way fast. But you're also going to start to see less about like sort of set and forget autonomy, and there's going to be a lot more systems that are supervised autonomy, meaning that instead of having one sprayer, put it in a field, walk away, it's going to be you're going to be running 3 sprayers with one guy, and think of the harvesting use case as a great example, where there's a lot of farms today that run more than one combine in the field at a time. Just, especially getting these custom operator crews. Mm-hmm. And there's typically a lack of really skilled operators. And so if you can take one of your really skilled operators or the farm owner, put him in the cab of one of these harvesters, but give him control over the other 2 or 3 that are in the field with him. So he's leveraging his expertise about how to do the job really well across multiple machines at the same time. That becomes really valuable very quickly, I think. And that's where I think you'll start to see stuff get commercialized first. It's going to be less about walking away from something and much more about how do I leverage my skill set across multiple machines.
Yeah.
Now,
yep.
You mentioned, right, we have some exposure outside of ag, and what we've seen also, which is really interesting in the construction mining space is...
That's my next question. Yep.
Is about taking, detaching people physically from machinery, but not from machinery, right? So allowing for teleoperations to happen. And that's another thing that I think you'll start to see in ag. And it might be in some of these countries like Brazil, where you have these massive fields and you have very low skilled labor, where you could centralize your operators into a certain spot, then they're running a piece of machinery halfway across the country to do that job. And they've got all the data, just like your monitor would tell you today if you're sitting in the cab. They've got all the data there to make those decisions. And then you have, maybe one support guy that's supporting 4 or 5 different harvesters in that field. So, if you throw a chain or something breaks, he's there to fix it, and he doesn't have to drive, halfway across the country to go do that. But I think you'll start to see that. You see that a lot in like these mining operations where, they'll have a big mine site in a super remote area, and they just can't find people consistently, and so they can go to a city center, hire some really skilled operators, guys that maybe retired down in Arizona, but they're happy to sit in, operator station for several hours a day and run something in Alaska. And that becomes, I think, really powerful.
Yeah, that was my next question. Like in your scenario there, I mean, and you kind of answered a little bit already, but looking at ag versus construction versus industrial stuff and like those kind of things. Like, for example, a good friend of mine is in the lift truck industry, right? And there's a lot of autonomy in the lift truck industry, and inside those warehouses where they've kind of got everything mapped out, and you got lift trucks running all over the place, putting stuff in slot A22, and they go pull something out of B3 and whatever else, do all that. Do you feel like, I feel like that industry, and we're seeing it already, where it's more widely accepted just because of the labor issues and stuff that you see come into play there. But do you see more growth, more rapid growth with, especially on the mining side, where you're doing, you're mining out, putting in a truck and driving the truck out, or whatever it is that you're doing, conveyor belts or whatever it is? Do you see that being a way more widely accepted, maybe going to be 10 years ahead of ag, 15 years ahead of ag when it comes to autonomy and how those things play together? Kind of like just like, a guy sitting in a room monitoring a bunch of monitors, kind of figuring out what's going on.
Yeah, I think so. I mean, mining, I would already argue, is ahead of ag in terms of automation or autonomy. And, there's mine sites today that are basically running a whole fleet of autonomous trucks for haulage. And there's some underground autonomy applications as well. The value proposition for mining is just so extreme that it's very hard to not use autonomy and stay competitive. And so just by the nature of, I mean, these haul trucks, for example, run 24/7. They have a full-time crew per truck of 5 people. So they, run 4 shifts, and they, have one guy that's rotating on and off, so he can have a weekend. So you've got 4 or 5 full-time people per truck, and you do the math on that. It doesn't take very long for an autonomy system to pay off.
Right.
If you can reduce that cost and that labor dependency. So yeah, I do think the value proposition in certain industries will drive it faster, and in some cases, same thing for warehouses, right? I mean, it's 24/7 kind of operation where you're constantly moving stuff, and it's a very structured environment. It's very repeatable. Part of the challenge you run into in different off-road applications is where it's not as repeatable and it's less structured, and that's the harder part to solve for in some cases, because you can't kind of install infrastructure on a field-by-field basis to do autonomy. You really have to have the intelligence side on the machine buttoned up pretty good, and the sensing piece, right? And you mentioned it earlier. You've got to know, if you're not sitting in the cab anymore, you have to have the sensors on the implement to be able to tell you if the quality of work is there. And that's something that we look at a lot, and I think it's still an unsolved part of the equation today.
Yeah.
And I'm very excited about approaching that. One of the things that we have invested in, and we'll have a product coming out for the end of next year, is to do quality of work sensing for tillage type applications, where you can monitor the job quality through all the dust and debris, and measure residue, and understand, if something's plugged or something's broken, it picks that up. So if you're not in that cab anymore, you still get that information and can make better decisions. Honestly, I think you're even going to have more information and more data than you would had you been in the cab. So if you've ever tried to do tillage at night, you can't see anything that's going on behind you, really, in all reality, especially if there's any type of dust. You have to kind of almost turn back on the pass you did to know if it looked good. And I think with some of the sensing capabilities that we're investing in, that'll be really impactful. And so, it's kind of an incremental step-by-step process to solve some of these challenges, but they're definitely solvable, which is exciting.
Right on. Okay. I know we only have a couple minutes left. I know you got a hard stop coming up here. Final thoughts on this, Colin, as you take a look what's going on here. What do you see coming at us, and how should we, if I'm an end user, how should I prepare my farm for what's coming?
Well, it's a great question. I mean, there's a lot of things coming. There's a lot of investment in the space. There's a lot of different companies working on different aspects of the challenges for autonomy. I think the key thing is to really understand what is the ROI and clarify that before you make any type of decision. Make sure you understand how can you use it and save actual cost. And there's a lot of factors that go into that for any given operation. I think it's going to depend. But if you can hand off or repurpose labor, that's the most direct way to do it. It's the most tangible way to pencil ROI. But it's also not probably going to be, in the end of the day, the biggest value proposition. So it's harder to do the math on safety. But to me, that's one of the things that maybe doesn't get talked about enough related to autonomy. If you look at, the most dangerous jobs in the world, there's crab fisherman, and then there's like farmer, right?
Right. Yeah.
So it's like,
Yep.
It's dangerous, and it's obvious why, right? You're putting human beings in extremely close proximity of very high horsepower machinery that can kill you in an instant. And so the more that we can do as an industry to even just create distance between people and machinery is going to pay dividends, right? And it's hard to put a value on saving somebody's life or limb, but that's something also that really should be considered as a part of the decision-making metric or matrix when you're looking at this type of technology. Is can I create a safer environment for my workers and myself and my family by leveraging some of this? And it doesn't always have to be full autonomy, right? I mean, I think that's the fun, kind of sexy part to talk about, but there's a lot of like basic things you can do with this technology that isn't going to mean like day one you're saving an operator time, right? It might just mean, hey, you're able to supervise something remotely that you couldn't before.
Right on. Well, Colin, I appreciate you being on the podcast, man. If folks want to reach out to you and get more information about what you're doing, what's the easiest way to do that?
Yeah, just go on the website. It's mach.io, and you can drop us a line on there, and also look us up on LinkedIn or social media. We've got some cool pictures and videos we put out there every once in a while, some of the stuff we're working on. So I always love to hear from end users that are looking at autonomy, because that does help us as we talk to different OEMs. Understanding in practical reality what it is you're trying to do as a farmer is very valuable for us to talk to some of our OEM partners about. And say, hey, look, you've got this machine. Here's this need. Let's put the two together.
Yep. Right on. Okay. Well, Colin, I appreciate it. I'm Casey Seymour with Moving Iron Podcast. Check me on Facebook, Twitter, and Instagram at Moving Iron LLC. Go to LinkedIn at Moving Iron Podcast. Check out the YouTube version of this on the YouTube channel, which is Moving Iron Podcast YouTube channel, and go to movingironllc.com for everything Moving Iron related. Colin, good to connect with you again, man. Glad you could come back on, and I hope we do this again sometime.
Yeah. Thanks, Casey. Thanks for having me.
All right. Appreciate it.
Take care.
The Moving Iron Podcast is brought to you by these great sponsors. Are you looking to value your equipment more accurately, target the right buyers and close more deals, reach your ideal customer? Then look no further. Fusible isn't just about ag data, it's about action. Our best-in-class solution empowers you to value your equipment accurately, make informed decisions, and find the perfect prospects. Ignite your dealership's growth at fusible.com/moving iron-podcast. Out in the field, every decision counts. You wouldn't plant without testing your soil, so why would you prospect blind? Introducing EDA, your one-stop shop for ag equipment intel. EDA goes beyond specs and prices. You get deep dive data on every piece of equipment like UCC filings that help track ownership changes and uncover potential sales leads. D&B firmographics, which help you understand the financial health and buying power of potential customers. Market trends that help you stay ahead of the curve, and insights on equipment demands and pricings. With EDA, you're not just looking at data, you're seeing opportunity. Find the right buyer, sell smarter, and build lasting relationships. Visit edadata.com for your free demo and unlock the power of knowledge. For over 80 years, Iron Solutions has been your go-to data source for ag dealers, lenders, and manufacturers. Get powerful appraisal and value forecasting tools that fuel profitable decisions anytime, anywhere. Get your free demo at ironsolutions.com. Iron Solutions, confidence in every click. Today, there are many ways to finance ag equipment, but nobody delivers simple, fast, or flexible financing like AgDirect. Learn more about your options to buy, lease, and refinance equipment at agdirect.com. Valley Transportation has been hauling ag and construction equipment across the country for the past 33 years. Call Parker at 800-657-4910 for all your trucking needs. At Valley Transportation, our goal is to help you reach yours.
When you partner with Axon, you immediately gain access to a full range of products and solutions designed to meet the complex needs of today's grower. We carry all major brands and sizes of tires and wheels. We specialize in large diameter wheels for large equipment. We have one of the largest OEM replacement wheel inventories in North America. Known for extreme flotation setups, duals, and triples, we have wheels for all makes and models of tractors, sprayers, combines, and grain carts. If we don't have the wheel in stock, we'll custom build, sandblast, and paint in-house. There isn't a more vast inventory in North America dedicated to helping dealers move more iron. With facilities on the West Coast and in the heart of the Midwest, leverage our 230,000 square feet of indoor inventory to solve any problem a grower may have. Move more iron with Axon.
Moving iron in the 21st century. Hard-working people working hard for you and me. Moving iron time and time again. Through the years you'll find us here. Moving iron.